Welcome to this comprehensive Viva Voce guide for the sonometer experiment in the physics laboratory. This video will cover the core principles, practical laws, and essential formulas you need to master the physics of vibrating strings. The objective is to study the relationship between frequency, length, and tension of a stretched string. Remember the core laws. Law of length states frequency is inversely proportional to length, and the law of tension states frequency is directly proportional to the square root of tension. The crucial formula is shown here. Let's test your knowledge. Question 1. The sonometer demonstrates resonance and the laws of transverse vibrations of strings. Question 2. Frequency is inversely proportional to the vibrating length, so the answer is D. Question 3. The hollow wooden box acts as a resonator, amplifying the faint sound. Quick quiz 3. Question 4. The paper rider is thrown off when the string's frequency matches the tuning fork's frequency, confirming resonance. Question 5. Linear mass density, M, is measured in kilograms per meter, kilogram per meter. Question 6. Increasing tension by 4 times doubles the frequency, as frequency is proportional to the square root of tension. Question 7. In the fundamental mode, the wavelength is twice the length of the string, or 2L. Question 8. If the radius doubles, the frequency is halved, since frequency is inversely proportional to the radius. Question 9. An AC current in a magnetic field causes the wire to vibrate at the current's frequency. Question 10. Plucking the wire at the center ensures an antinode forms there, exciting the fundamental frequency and suppressing even harmonics. Question 11. The combined effect of radius and tension results in a frequency ratio of 1:1. Question 12. When the mass is immersed in water, tension decreases, resulting in a new length of 37.4 centimeters. Question 13. With the wire beating 4 Hz with a 500 Hz fork and beats dropping after tension increases, the original fundamental frequency must be 248 Hz. Question 14. Plucking the wire at L/4 from a bridge suppresses the 4th harmonic and its multiples. Question 15. The velocity of the transverse wave, given the parameters, is approximately 62.6 meters per second. Let's review the fundamental concepts. A sonometer studies transverse vibrations and verifies the laws of vibrating strings based on length, tension, and mass density. The law of length states that frequency is inversely proportional to length, with constant tension and mass density. The law of tension states frequency is directly proportional to the square root of tension. In applied concepts, the paper rider must be midway to excite the fundamental mode. The holes on the sonometer box prevent damping by allowing the internal air column to communicate with the outside. Remember that increasing tension by 4 times doubles the fundamental frequency. For practical laws, linear mass density is determined by dividing the total mass by the total length. In an AC sonometer, frequency is twice the mains frequency, 2F. Thicker wires produce lower-pitched sounds because higher linear mass density decreases frequency. Here is a summary of the core formulas for the sonometer experiment. Key formulas include linear mass density, AC frequency relation, and transverse wave velocity. The fundamental frequency law combines length, tension, and mass, and is shown here. Thank you for watching this video on mastering the physics of vibrating strings. Like, share, and subscribe for more educational content.